Hello, everyone. Welcome to this monthly webinar on the Southwest drought conditions and resources. My name is Joel Lisenby. I'm a Regional Drought Information Coordinator at NIDIS, which is the National Integrated Drought Information System. For those of you who are not familiar with this webinar series, we usually try to keep these briefings pretty casual. They last about half an hour. We try to highlight in that half hour the state of the climate across the Southwest, especially when it comes to drought. And we'll also look at some of the great work that's happening across the region and some of the other forecasts that help us get an idea of what we can expect in the months to come. These 30-minute briefings began during the 2020 Southwest Drought as part of the Southwest Drought Learning Network's monitoring and reporting team. And we're going to continue these as long as there's interest in this type of information and in this format. I would like to just quickly acknowledge a handful of co-organizers who helped put these briefings together. It takes a lot of hard work every month to line up presenters and to manage the behind the scenes, and the list of people that are helping with this keeps growing. So I'm not going to list all of them because I'd actually be worried I'd leave somebody out. But I would just like to give a big thank you to everyone who's helped put this together. You know who you are. The Southwest Drought Learning Network is a network to support peer-to-peer learning by linking climate service providers in the region with resource managers and resource managers with each other in a way that we hope can share ideas and experiences that will inform and it will provide the information and increase resilience when it comes to drought across the region. If you'd like to be involved with the Southwest Drought Learning Network, send me an email, or Gretel Follingstad, who sent the email that had the invitation to this webinar on it. Also, if you're interested, our annual meeting is coming up at the end of September in Albuquerque. It's an open meeting. Everybody's welcome to it. Just reach out to me and I'll give you the details for the meeting. Just quickly before we get started, a few logistics. This webinar is being recorded. The recording will be made available on NIDIS's YouTube channel, also drought.gov/webinars. Everybody is beginning this webinar muted. Nobody will be able to talk. But if you would like to ask a question, you can do so by typing your question into the questions box. And we will moderate the questions and ask the presenters at the end. Today, the questions will be moderated by Gretel Follingstad. She's the Intermountain West Drought Early Warning System Coordinator at NIDIS. And then at the end of the webinar, you'll be invited to take a short survey and even provide some information about some topics you'd like us to cover in future webinars. Now, I'd like to introduce our speakers for today. First, Erin Ann Saffel is the Arizona State climatologist. Go ahead and wave, Erin. Hi. Erin is the director of the Arizona State Climate Office and senior global future scientist with the Julianne Wrigley Global Futures Laboratory. Her main research interests are flood and drought, as well as impacts of the urban heat island. Thanks very much for being here with us, Erin. Following Erin, we'll hear from Shauna Tiggy. Shauna is the hydrologist with the Bureau of Reclamation, Lower Colorado Basin region. She has worked with the river operations for 19 years and currently is the team lead for daily and midterm operations. She leads the operational development of the Colorado River Midterm Operations Model, known as CRIMS, in the Lower Basin, and coordinates with her local team and the Upper Colorado Basin. I'm starting to trip over some of these words. I apologize, Shauna. So she coordinates with her local team and the Upper Basin counterparts to publish the CRIMS 24-month study each month, something that I look at whenever the email comes up to look at what's coming. So thanks for your work on that. And that's used to determine the annual operations as well as the CRIMS ESP model runs, which provides probabilistic projections in the 2 to 5 year time frame. Shauna, huge thanks for being here. We're looking forward to your talk in a few minutes. So now I'm going to pass over to Erin to get things started.
Okay, I'm going to share my webcam, and hopefully we've got everything we need to go right in through there. We seeing everything okay, Joel? Oh, show my screen. Yet. One moment. There we go. All right.
Yes, we can see that now.
Great, that's wonderful. Thank you very much for your time, everyone. I'll go ahead and be brief with my discussion. I did want to go back to July for a little bit here, however, because it was such a record-breaking July, and it does set forward what we're experiencing here in August. And so just a little bit about that really persistent, strong ridge of high pressure that kind of set the place for what we experienced in the Southwest in July, record-breaking temperatures. And of course, Phoenix then had the hottest monthly temperature for a city in the United States. We averaged a temperature of 102.7 degrees in July. So really tremendous event in July. And that really was because June was so cold. We had such a cold and wet winter. It delayed the onset of the monsoon. To that extent, lack of thunderstorm activity really kept things really hot in July. And so looking at July conditions here in the Southwest, breaking records in the Four Corners region, the hottest July for the Four Corners states, and the fourth hottest when we're looking at California, Nevada. Taking a peek at the SPEI for July, because the SPEI takes into account not just the temperature, but also the precipitation. So not just both of those, looking at how they couple together. We look at that quite a bit for Arizona, looking at our long-term drought, and you can see that just for July, record level SPEI levels in July. So really an extensive July setting up. But fortunately, we had such an amazing winter here in the Southwest when we're looking at what's been going on for the water year. So looking at the percent of average precipitation for the water year, you can see that we're still doing quite well in many locations for the water year precipitation. And in California, there are above average water year amounts in many locations. They had a great June, which is usually a dry June in California, and that really put them over a lot of those numbers for the water year. And even looking at the average temperature, the departure from the average for the Southwest, you can see all of those greens in that map. So even though that July was exceptional, really coming off of October, November, December, January being very, very cold, really kept things cool. So that's actually a benefit looking at these kinds of things. However, we know that our drought is playing a role in not just the precipitation, but also the temperature, looking at how that might have been impacted by that really hot and dry July that we all experienced here in the Southwest. And you can see that I pulled in the drought monitor for the end of June, the start of August, kind of looking at where we're at right now. And you can see that through July and August, we did see expansion in Arizona, New Mexico, and Colorado. You can see that New Mexico is now seeing the extreme levels of drought in the lower corner. And we're seeing that expansion here in Arizona as well. So some expansion, hopefully with the precipitation that was just received, hopefully mitigating some of that expansion. And part of the precipitation that we've been receiving here in Arizona has come on the west side of Arizona from the tropical system Hilary that came into right along into California, upwards into Nevada, and we'll take a look at some of those areas that were impacted by Hilary as it made landfall. So tropical systems in this part of the country really aren't unusual. Later August, September, October, they tend to come with El Nino events. They tend to start picking up a little bit. They do impact with precipitation in some locations, and they can bring a lot of precipitation in a very short period of time. The setup with Hilary was really kind of a textbook setup when we're looking at what we call a transition area for monsoon, a high pressure, ridge of high pressure kind of over in the middle part of the country. We had a low pressure system coming in from the Pacific. So just kind of like what you can see in the Atlantic Basin when you are trying to funnel in those tropical systems, they can go right in between those two pressure centers. And of course, that's what we saw with Hilary. It just pushed around that ridge of high pressure and came right on in. Of course, it made landfall in Mexico as a tropical system, tropical cyclone. Didn't quite make it as a hurricane, but it did bring a lot of precipitation. As these tropical systems do come in, they're bringing a lot of precipitation in a very short period of time. And you can see kind of that trending around that ridge of high pressure as it pushed in. And you can see for the last 7 days, upwards of 800% average precipitation in a lot of locations, especially here, California, Nevada. You can see Oregon and Idaho and a little bit of Montana getting that precipitation. So definitely bringing in a lot of precipitation in a short period of time. A lot of record breaking for those particular dates when we're looking at that precipitation. And of course, then the impacts that come with this precipitation in the Southwest. Heavy intense precipitation means flooding, means mudslides, means power outages, means damage to our roadways. And that's absolutely what we're seeing in those locations that were impacted quite extensively. This is interesting. I appreciate the WPC coming together and putting out this map of who's been impacted by tropical cyclones. And you can see who's been impacted by Hilary the most. So this will be the maximum rainfall caused by a tropical system in that state. And so we're going back over 100 years, and you can see Nevada then takes the cake with Hilary, as does Oregon, Idaho, and Montana. So their biggest impact from a tropical system was Hilary in this event. And just a little bit about what we're expecting. So during an El Nino event, and that's what's been picking up, we can tend to have more tropical systems here on the Pacific side, the Eastern Pacific side of things that can impact us here in the Southwest. Not so much do we get these Atlantic systems that make their way across into Arizona and Nevada, but there's an invest being evaluated that could potentially come into Arizona and New Mexico. Time will tell. We'll have to take a look at that. And when we're looking at what may happen in the future, so looking at the September outlook, it does tend to look warmer than above average conditions. But you can see in California, Nevada, Arizona, we have that little bit of above average blue for precipitation in September, related to perhaps tropical activity still coming in, but we'll have to wait and see what's going to go on. We do have El Nino on track to persist through winter 2023-24, and with the southern tier of the United States, El Nino tends to statistically bring more storms. We tend to have more precipitation, so we're all very hopeful that we're going to have another wet winter. So I thank you very much for your time. I'll go ahead and stop sharing my screen, and I'll be happy to answer questions as we're done with our talks.
Thank you for that, Erin. Shauna, I've just given you presenter permission. When you see that pop up, you can just go ahead and begin.
Great. Can everyone see my screen now?
Yes, and we can hear you too.
Great, perfect. All right. So I'm going to start out talking a little further back in time. I'm going to go back a year ago at this time, August 2022. So on the left-hand side, I've got the Lake Powell end of month elevation projections from our August 2022 24-month studies and our CRIMS ESP run. On the right-hand side, there is the projections for Lake Mead end of month elevations. And at that time, you can see they were very, very pessimistic. And just to give you an idea for those of you who might be not quite so familiar with these charts, this line over here, 3490, represents the minimum power pool at Lake Powell. That is the lowest elevation that Lake Powell can release water and still generate electricity. And we were projecting that Lake Powell could fall so low that it could not generate any hydropower in less than a year's time. So it was a pretty dire situation that Lake Powell was looking at. On Lake Mead, it was not quite as dire. Lake Mead's minimum power pool is elevation 950. We were not quite projecting to get there within the next 2 years, but we were projecting Lake Mead to fall below elevation 1025, which is significant because that is the lowest elevation at which shortages and drought contingency plan contributions are defined in the current operating guidelines. So then this happened, as Erin just talked about. This slide shows water year 2023 precipitation and snowpack above Lake Powell on the left and in the Salt Verde Basin on the right. Snowpack above Powell peaked at 161% of the peak seasonal mean. Cumulative water year precipitation to date is currently tracking at about 114% of average, so fabulously wet conditions. In the Salt Verde Basin in Arizona, snowpack peaked at 246% of the peak seasonal median, and cumulative water year precipitation is now at 144%. Just a week ago, it was at 138%. So the recent storm over the weekend definitely increased that water year precip to date. And these wet conditions had huge impacts on operations as well. At Lake Powell, the annual release volume had initially been set to 7 million acre feet, which is the minimum defined in our current operating guidelines. But in April of 2023, the Secretary determined that there was sufficient inflow to warrant a shift to balancing releases, where Powell will release water up to 9.5 million acre feet in an effort to balance the contents of Lake Mead and Lake Powell, which is to make sure that they have equal contents at the end of the water year. And I'll show you the impact of the wet lower basin hydrology in the next couple slides. This table shows the intervening flows between Glen Canyon Dam and Hoover Dam. This first column is the 5-year average. This second column over here is the preliminary observed flows. And you can see that in March through June in particular, this is the runoff season for the Virgin River Basin and other smaller basins above Lake Mead. These inflows were pretty well off the charts compared to our recent history. March was at 234% of average. April was at 405% of average, May 505% of average, and June 280% of average. If we were to just get our 5-year average inflows for the remainder of the year, we would end the calendar year at 165% of the 5-year average for intervening flows into Lake Mead. That is 510,000 acre feet, which at current elevations corresponds to an increase in 6.5 feet in elevation. These charts here show the effects of the wet conditions below Lake Mead. During the high inflows in the Salt River project, they had to initiate flood control releases. And that water made it all the way down to Painted Rock Dam on the Gila River, down in southern Arizona. Consequently, the Army Corps of Engineers had to initiate flood control releases out of Painted Rock Dam, and those flows are represented by the blue line on this chart on the left-hand side. Now, most of that water seeped into the ground before it ever reached the confluence with the Colorado River down in Yuma, but the USGS measured about 87,000 acre feet at the Gila River at dome gauge. That represents the volume that arrived at the confluence and could be used to meet delivery requirements to Mexico. Additionally, there was a lot of inflow into another Army Corps reservoir in central Arizona called Alamo. Again, the Army Corps had to initiate high releases at Alamo Dam into the Bill Williams River, which flows directly into Lake Havasu. And we estimate about 108,000 acre feet of releases from Alamo reached Lake Havasu. So in total, we estimate close to 200,000 acre feet of additional inflows that arrived in the Colorado River in 2023. And this water could be used to meet water deliveries rather than releasing water out of Lake Mead. And this doesn't even take into consideration the conservation programs that the water districts have been signing up for. So more inflows, less water demands downstream have meant big improvements in Lake Mead elevations. On August 15th, Reclamation published the August 2023 24-month study. And these results, again, are used to set the operating tiers for 2024. This chart here is the Lake Powell end of month elevation projections. Based on the most probable 24-month study projection of end of calendar year elevation, Lake Powell will operate in the mid elevation release tier in water year 2024, and it will release 7.48 million acre feet over the course of the water year. That is not a balancing release. It's pretty well set for the year, so that will not be changing. Unless, of course, we see something like what happened 2 years ago, where conditions really deteriorated, and in order to protect Lake Powell, they reduced the release in the middle of the year. You can also see that conditions have improved to the point that we are no longer projecting Lake Powell to fall below minimum power pool for the next 2 years. And certainly there is still a lot of uncertainty regarding the hydrology in 2024. We do see some traces projected to fall into the 35-25 foot range within the next 2 years. So while we are happy for the reprieve, we are by no means out of the woods. As I think everyone on this call knows, one wet year does not make up for many, many dry years. This next slide shows the projected Lake Mead elevations from the August 24-month study. And as one might expect, due to a higher water year release volume from Lake Powell, as well as higher overall tributary flows in the lower basin, conditions in Lake Mead are projected to improve to the end of the calendar year. Based on the most probable 24-month study projection of end of calendar year elevation, Lake Mead will operate in a level 1 shortage condition in 2024, with additional contributions required by the Lower Basin Drought Contingency Plan and by Mexico under the Binational Water Scarcity Contingency Plan. And just to note here, despite the improvement in conditions we've seen this year, you can still see that the range of projections out to 2025 indicate that there are still scenarios that could return Lake Mead into these lower elevations that we have experienced recently. And then I'll also just note that we are currently in the process of finalizing the CRIMS ESP run, and we will soon have the 5-year results available, hopefully by the end of the month. I was asked to touch on a very exciting project in the Lower Colorado Basin, and that is this monsoon forecast project. First, I want to credit Andreas Prine and Aaron Towler of NCAR in Boulder, Colorado. They are the primary investigators on this project, and you can see their paper that came out of this project if you go to this website near the top of the page. And just a very quick summary, because I know we don't have a lot of time. What Andreas Prine did was use the ECMWF model, which stands for European Center for Medium Range Weather Forecasts. He used this to get forecasts of low-level atmospheric moisture to define and project 3 distinct large-scale weather types in catchments in New Mexico and Arizona. These 3 weather types are wet or monsoon, normal, and dry. Then Aaron Towler took it one step further and developed statistical regression models to try to predict if the precipitation would be above or below the historical median, as well as the likelihood that the precipitation would be in a lower, mid, or upper tercile. At the bottom of the slide, I have a couple sample charts of the projected weather types in the Arizona West catchment. On the left, you can see the June 2022 forecast, and you'll notice there's a high distribution of blue or wet days. And you know, 2022 had a very wet monsoon season. In contrast, on the right, we have the June 2023 forecast, and there's a much lower distribution of wet days in 2023, with the peak being in that kind of mid to late August timeframe. And what have we seen so far this summer? Pretty dry until less than a week ago. So we're pretty excited that this forecast approach might have some real operational uses. And I'll also note that we were just granted funding under Reclamation's Facilitated Adoption Program, which is a new program designed to help regions operationalize research so we can put the new science to use. So we'll be spending the next couple of years continuing our collaboration with NCAR to help move this to the next level so we can apply these forecasts and improve our operational models. And that pretty much wraps up my presentation. I just have the summary here. I can turn it back to Joel for any questions.
Thank you so much, Shauna. Great presentation. I'm going to hand over to my colleague here at NIDIS, Gretel Fallingstad, to moderate the questions. Go ahead, Gretel.
Thank you so much, Joel. We had one question in the chat that was answered, but for others, it was whether or not there is an URL for the map with peak precip from tropical cyclone remnants. And Joel, I'm not sure if you answered or Aaron answered, but it is Twitter, and that is NWSWPC status, and then a number. So I think that's your source. Is there any other comments on that data and findings that you want to add for the rest of the audience? Okay, I'm going to take that as a silent, the pregnant pause of no. I don't see any other questions currently, so if the audience would like to submit any further questions, please do so. I do have one question, and that is related to the weather type distribution results, and that is whether New Mexico results look different than Arizona results, knowing that New Mexico didn't quite receive a monsoon to speak of, and we didn't get any of the Hurricane Hilary tropical impacts. And so I was just curious if you have any thoughts or reflections on New Mexico.
Yeah, thanks for the question. Yeah, we have definitely seen that this forecast is a little bit more skillful in the Arizona catchments than in the New Mexico catchments. And we believe that that might be because whereas Arizona is predominantly impacted by storms on the Pacific side, New Mexico also has the influence on storms on further east from the Gulf of Mexico on the Atlantic side as well. So one of the tasks in our facilitated adoption program, one of the tasks that NCAR is going to be looking at is incorporating forecasts from the Atlantic as well as from the Pacific to see if they can improve the forecast skill in New Mexico to match the skill in that we're seeing so far in Arizona.
Excellent, thank you. And then maybe one other question about the 24-month study for Lake Mead and Lake Powell with El Nino in mind, and this might be a tag team between Aaron and Shauna. With El Nino in place and moving, usually when we move into El Nino years, we have more precipitation over the winter. And I'm curious if what your thoughts are, and I know you can't predict it, but given we had such a huge water year in a La Nina, if there is any research thoughts or projections that you're hearing within your own shops around what an El Nino may look like this year, given our last 12 months of precipitation patterns.
Shauna, I'll let you go first if you have any ideas.
Oh, I was going to ask you if you wanted to go. Well, from what my understanding is that El Nino has a pretty strong correlation with wet conditions down here in the lower basin. So in the Arizona, Southern California area, we might see some wetter conditions. And how that would affect the 24-month study modeling and operations is that would be really helpful in reducing water demands downstream of Lake Mead. So we could store more water in Lake Mead instead of releasing it for uses. It's my understanding that there is not as high a correlation with wet conditions in the upper basin though. So it's really unclear how El Nino could affect upper basin snowpack. And I don't know, Erin, if you have more to say about that.
Well, I'll pop in, but that's exactly what it is. We have statistical relationships with El Nino bringing precipitation. Now, we were so fortunate this last winter to have it be so cold. So then the precipitation stays in the form of snow, and that snowpack just didn't melt. It was about 2 to 3 weeks delayed, which is amazing when we're looking at our water supply. So we're not quite sure what we're going to get again this winter. Are we going to get more precipitation? Are we going to get colder conditions? We just have to wait and see, unfortunately.
Well, thank you both so much. That's really helpful information. And I think at this point, I'll turn it over to Joel to close us out in the last minute or so of our webinar.
Great. Thank you, Gretel. Another big thank you to Erin and to Shauna. Great presentations, very well done. Thank you very much. And thanks everybody for tuning in today. Again, the recording of this will be posted on drought.gov/webinars. I'll probably get it posted sometime later this week, and I'll send out an email, or I think Gretel will actually send out an email when it's posted. So that's it. That ends today's webinar. Thank you very much.